Today's video will demonstrate how to design a class that contains a collection. Hello, I'm James Helfrich. One of the most common things we implement with a class is a collection. In other words, it contains a collection of elements. The question is, how can we design the public interfaces so it's most convenient to the client and so the client can know what to expect? This video will demonstrate that with a live example. So just about every class working with collections needs to provide certain interfaces that the client expects. And those include how to insert elements into the collection and remove elements from the collection, how to retrieve an element from the collection, as well as how to update an element within the collection. We're going to be able to find an element in the collection, determine the size of the collection, and finally iterate through the collection. We will demonstrate this process with a collection of words, kind of a contrived example, I know, which will go through each of these common operations. So we'll begin by making comments for each of the operations, and then we'll implement them all in turn. So we'll start with the very easiest method, size, and that's just going to be a constant method returning an integer. Notice how I implement the code in the C++ file, and then the interfaces are in the .h file. Super easy to do. The next thing I'll implement is the insert method, and this is going to take a string as a parameter. I'm just going to pop that sucker right on the end of my list. Now notice I have to take care of the scenario when my list is already full. I can only have 10 elements in this contrived example. So if I fail to insert, then I'm going to return false, and if I succeed, I'm going to return true. Now the next thing I'm going to do is implement the remove function. And once again, I'm just going to remove the element off the back of the collection. If there is an element in the collection, then I'm going to return true. And if there's not, I'm going to return false. So I'm doing very trivial error handling at this point in time. Now the next thing we're going to do is the iterator, and this is going to be by far the most involved. So I have to have a forward declaration of my iterator, and I'm going to have two methods, begin and end. Now notice I have to create an entire iterator nested class, and it's going to have a single member variable, which is a pointer to my string. I'm going to have the default constructor, which is the null pointer. I'm going to have a copy constructor, which will copy the iterator from the right hand side. I'm also going to have a non-default constructor that's designed specifically for begin and end, so I can point to a specific location in the collection. Notice how I'm taking the time to line things up so I can really easily verify that I did everything right. Now my double equals operator is going to return a Boolean, either true or false, and I want to compare two iterators, so the full name of his words, colon, colon, iterator, colon, colon, operator, double equals, with the right hand sign be another iterator. And I'm going to just verify that P's are pointing to the same element. Now, of course, if I'm going to have the double equals operator, I'm going to have the not equals operator as well, and this can be rather trivial to implement. Now I also want to implement the increment operator. So I want to be able to increment my iterator by 1. I want to advance it. And so I'm going to do the ++ operator to do that. And the way we implement that is operator ++, and it's going to return an iterator by reference. And all I'm going to do is advance my P, and then I'm going to return star this. But I also want to not only ++ it, but it++, so I have to have a second parameter called postfix, and now I'm going to make a copy of the old iterator and then increment the new one and then return the old one, so I always return the old value. Now finally I have to use the dereference operator to fetch the element, and this is just going to do a star P, and now my iterator is finished. So with that, I have to create my begin and end. Now begin is going to pass a pointer to the first element in the collection, which since arrays in C++ are just pointers to the first element. I'm going to call the non-default constructor to the iterator with a words as a parameter. And then end is the first element off the end of the collection, so it's going to be words plus num elements or num words, and that will be a pointer to the first element off the end of my collection. What I'm going to do now is take this iterator that I created, and I'm going to update my remove so I can remove a specific element within the collection. And this is going to require me to shift everything over. So it's going to be quite a bit more involved than my previous version. I'm going to have two iterators, it next and it previous, and I'm going to take it next and assign it in previous, shift everything over as I advance through the collection. When I'm finished, I'm going to do num elements minus minus. Quite a bit harder than just removing an element off the end of my list. Okay, so next I'm going to implement the get method. So I'm going to get one word out of my collection. So I need to specify the index. So the most convenient way to do that is the square bracket operator, the array index operator. I'm going to pass an index as a parameter. Now notice how I'm just fetching the element. So therefore this is going to be a constant method. I'm not changing the collection, and I'm going to return a copy of the string. Now when I do update, it's going to be exactly the same code, except the difference is I'm going to pass this string by reference, and it's going to be a non-constant method. The code will be the same, but one has read-write privileges and one has read-only privileges. Okay, so the next method we're going to do is find, and it's going to return an iterator to the element that matches the string that we pass. And so we're going to have to do a linear search because this is unordered. We're going to find the first one that matches, and then if we can't find it, then we're going to return the end iterator. Okay, now that I finished all this, the next step is to demonstrate how it works. So I'm going to create a words object called W, and I'm going to insert an apple with w.insert. That's the obvious metaphor we want to use for inserting elements. And I want to insert another one, banana, sure. Let's see here, what would be another one to insert in? Another fruit. Let's see here. How about a grape? Well, an ABC, grape is not the right order, so I'm going to change that one to a cherry. There we go. Now it's the right order. I'm going to insert another one here. How about a car? Well, oh, hang on a second. Our car is not actually a type of fruit, so I better remove this one, .remove. So it's super easy for me to add and remove stuff. Which element? I need an index for that, so I'm going to index number 2 or 3. There we go. Now that I've inserted a whole bunch of elements, I want to be able to access them, and the iterator is a super convenient way to do this. In fact, the Gang of Four initially called the iterator one of their design patterns, so we use it so often now we don't think of it as a design pattern. For it equals w.begin, it not equal w.end, it plus plus, and I can access each element with a dereference operator star it. Now look how easy it is to walk through the collection. There could be nothing better. And this will work the same whether I have an array as an underlying data structure or a linked list or anything else. But I can also use an instance loop for auto word in W, cout word. And that's so cool because C++ will turn this into the iterator loop and it will just work. And that's the really cool thing about using predictable interfaces is now we have access to elements in the most convenient way. I'm going to find an element, auto it equals find banana, and then I'm going to remove it from the list with remove. And then I can remember I implemented both remove as an index and as an iterator. And there we go. So that's the end of our demo. You can learn more about how to design for collections in the collections section of the Metaphor chapter of the Software Design textbook.